questions. So today we have given question 2, 4, 2, 1 and saying number of good paths. So let's read the question. There is a tree and it is connected undirected with no cycle, right? Connected means all nodes are connected, right? The given nodes are connected, and it is undirected. There is no direction is given. Now it is saying consisting of n nodes we have, and it is from 0 to n minus 1, exactly n minus 1 edges. Means if the question is saying n minus 1 edges, means uh, all the given edges are connected with each other, right? Connected with each other like this, if we'll talk about. Okay, now you are given 0 index integer, that is called array vals, okay, of length n, where vals of I denotes the value of ith node. Okay, so it is saying we have we have array vals, and you are also given 2D integer ages, right? So ages a of I and b of I is ages of I is maintaining two nodes, right? I and bi. So this is the ith node, if you'll say. So it's connected with each other. These two nodes are connected with these is, right? Now denote that there exists undirected edge. It is a undirected edge and connecting node A and B. That's good. Now we have to find what is a good path. A good path is a simple path that simplifies and that satisfies the following two conditions. Following condition. The first condition is what? Starting node and ending node have the same value. Okay. So if there is 1, 2, 3 node, right? So if see this is a starting node, so its value is some value is, let's say 2 we have. So, okay, this is 5 we have, but the ending is what? 3, and this value is should also 2, like that. Okay, that's good. Let's read the another condition. If all nodes between the starting node and the ending node have value less than or equal to the starting node. Okay, so it is saying between the starting node and ending node, right, have value less than or equal. So as I have taken this one, this should not be, right? If there is 3 or 2, right, 3 or 2, then it's fine. Sorry, 2 less than 3 should also be not there, right? Either 3, 1, or we can say 0, less than or equal to. So these three value will get counted for the 2, but 2, it should not be 3 and 4 or 5, right? Understood. Let's understand. Return the number of distinct good paths. What we have to do? We have to return the number of distinct good paths, and then we have to count, right? So we'll take note that a path and its reverse are counted as the same path, so we don't have to reverse the path, right? Reverse path will not get counted, right? And so consider 0, 1 is 1, 0 is the same, right? An example 1 in which we will see that we will count the path. Okay, so we have given this example, right? And this example we have if we'll talk about all the nodes, right? How many nodes we have? We have node 1, 2, 3, 4 and 5. So these are nodes, right? And its value 5 nodes we have given. And so that if we'll consider single node, right? So these are single node. So total how many we have? 5 we have. Now we have to take single node is also a valid path, right? That we have given the statement. You will go back, you will see here it is saying a single node is also a consider a valid path, right? And that's why these 5 nodes are also a valid single due to single nodes, right? This is valid path is valid. Okay, so we have this one. Now if we'll talk about the good path, right? What is good path? Good path is if we'll consider this one, right? One we have this one, and this is what we have 1. But when we coming to this line, right? This line, right? And we're considering this path. Now in between 2 is coming. So 2 should be here. 2 should be not be greater than, right? It should be less than or equal to, right? So this is not the valid path. Now we'll consider this path, right? This 3 we have, and here also we have 3, right? In the blue color you can see. So we'll move like this and we'll check this path, right? So in between 1 is coming, that is less than equal to, and 2 is also coming less than equal to 3. So this is a valid path. So plus 1 will say that there is one good path, right? So if we calculate, total is 5 plus 1 is 6, and you can see here we have output is 6, right? So there are 5 good paths consisting, if you'll see the explanation, 5 good paths and one additional path. This is this path, right? And that's why we can say that this is the output of this one, right? If you'll consider of this one, what we have 0, 1, 2, 4 and 3. Similarly, if you'll consider these 5 nodes, so that there's 5 uh, single node we have, so this is the 5, and there is 2 additional paths we have given, 0 to 1 and 2 to 3, right? 0 to 1, this is our valid path, and 2 to 3, 2 to 3, if we'll talk about this one, sorry, this one. Okay, so let's consider that if there is only one, so we'll return only one, okay, due to single node. Let's go to the code section and we will understand. Okay, LeetCode code browser, and we'll start from here. So we have given number of good paths, right, in which we have given vals in the array form, and then we have edges in the 2D array form. Okay, so what we will do here, we will consider the approach union find, right, and we'll use this one, right? So what we have to do, we will take some we will find for urgency list, right? So we will start from here and we'll take urgency list. So urgency list will take, okay, we'll take adjacency list, okay, and this is our what, we'll take this time a hash map, right? So we'll take new hash map. Okay, so this hash map will be our map, right? So we'll take map, and this is our integer, right? We'll take integer as a node. This is our node, and each node will contain a list of integer, right? So we'll take list of integer or nodes, right? This is our neighbor nodes, integer, right? This is our urgency list. Now we have created first urgency list. Now what we will do here, we will move to all its edges. We will traverse all its edges and will get other its nodes. We will maintain our urgency list, right? So we'll have this one edge, and if we'll talk about each edge, right, each edge is what, this one. We'll start from here to here, and this is our list of edge, right? List of neighbor will come from a single edge, right? So from the edges we'll get one edge at a time, and each edge we will get two nodes, right? If we'll talk about, we have node 1, node A will say, and this node is what, our will come from the edge, right? Edge of 0. Got it? Now if we'll talk about node B, right, what we have, we will get from what, is ADGS at 1, correct? Node A and B come will have from the each edge, right? Each edge will consist of 2 nodes. So node 1 will say, node 2 will say, right? We can say also. So I'm taking node A and node B at a time. Now what we will do, we'll check the urgency. We have, this is hash map, right? So we'll check first if this is absent. So there is a function compute absent, right? If that is not there, so we have our node A, and this node A will contain a list of what value of its neighbor node, right? So we'll do like this, new array list, and we'll pass what, integer as a generic, and this is done. Now we'll add node over if it is not present, that is about node B, right? Similarly we'll do for node B. So if node B is not present, then we'll add its all neighbor can be B. A. Now this is done, so all our urgency list will maintain. This is an example of given nodes value, right? So all the blue color, it is saying that its value, right, and it's same nodes we have. Okay, so if we'll talk about 0, its value is what? 1. Next what we have? No other, we have the same value. That's why we are maintaining in the map, right? So let's suppose this is our map. So at index 0, what we will doing? We will store two things. First, its value and the same value, right? The value will store value and same nodes. Okay, this is our key and this is our value over the map. Okay, so first one will come, its value is 0. Similarly, we'll have 2 for node 1. Node 1 we have, node 3 is here, and node 4 is here, right? Like that. Sorry, not this one. Node is 6 is here. So we'll store all the value here like this. So we will store all key and value like this. Value of all, value of 2 of all the nodes, right? Let's suppose we have a value equal to 1. What? We have value equal to 1. So there is only one node with value 1. Okay, so if we'll talk about this one, this node 0 is have value 1, and so if we'll do union find, right, how we'll get it? You will see that the size is 1. Why? Because there is a formula, size into size plus 1. Okay, this is the formula, and by will 2. So if size is 1, then we'll do 1 plus 1 by 2, and that is 1 by 2 into 2, and that is 1, correct? So there is only one good path, that we are saying that all single will contain one good path. One single node have one path, not good path, but it's a one path, right? And that's why we are getting that one. Now if we'll talk about value 2 equal to 2, there is 3 nodes, 1, 3 and 6 with value 2, correct? And as you can see here, 2 and 3 is there. So if we'll talk about the size, right, size, what we have formula size into size plus 1 by 2, correct? So that's why we are getting size 2 into 3 by 2 equal to 3. Okay, and similarly for this one, what we have 1 into 2 into 2 by 2 equal to 1 equal to this, right? So this two size. So if we'll count this one, so 1 plus 4 is how many size we have? 5 have good paths we have till now, right? Now if we'll talk about value 3, right, what we have 4, 7, 8 we have, right, is having value 3. So if we'll talk about the size, how many we have? 3 size we have. So 6 good path will come from here, and previous is 5. So 5 plus 11 is what? 5 plus 11 is 5 plus 6 is 11, correct? So till now we have this one. Similarly, if we talk about value 4, we have two nodes, we have 2 and 5, and its value is 4. So if we talk about, if we calculate, this 3 good path will come, and previously we have 11. So total is 14 we have good paths. So like this we will traverse and we'll do that, right? So let's continue the coding and understand. Right? And now we have understood how we calculate our we can say our value, right? Value. So let's see, we have given this val, right, this val, and we have to find the mapping value for all the nodes having the same value in the sorted order of the value, right? So how we'll do that? Because we know we have the vals we have, right, vals we have of all the nodes, right? And now we have our adjacency also. So we'll take a int n equal to what we have given, vals and dot our length, right, this one. Now we will calculate its all the nodes, right, value to nodes we'll say. So let's tell map what? Map of value, map of values of nodes, right? Values of nodes, you can say. All nodes we have given, right? And that we have seen just now, we have maintained our nodes, we will maintain, and that we have to make sorted. So for the sorting we have tree map that will sort automatically, right? We'll take tree map, and that tree map will take what? Tree map, and this will store two things. One is its integer, its node, sorry, its value, and all its node. So this will come in what? List of integer, correct? We have taken the map, we have seen the map, right? That one. Now two thing is there. We have one, its value, and all the nodes will store, correct? Like we have seen. Now we will move to all its node. We'll start with what? I equal to 0, and then I should be less than what? N, and I plus plus, like this. So what we have to do? This node we have to maintain. How we'll maintain this? We'll add here. We'll check compute if absent, and we'll have our we are passing vals, right? So first we'll pass its val value at what? At some at its all nodes, right? So at a time one node will pass, and we'll pass its value. We'll store value and all the nodes that have the value. So I'll take like this, a new array list, and we'll pass integer, and we'll say like this, and we'll say what? We'll do add I, correct? I is what? Its node value, and val of I is what? Its value, right? Value that was seen in the blue color is this val of I, and I is our node. Okay, so we have maintained our what? Value map. Okay, now we will do union find, right? So to doing the union find, what we will do? We will create a class. How we'll do that? We'll take a union find is a class, right? And this will our we are doing the DSU operation, right? So we'll say our union will do union, right? We'll find the union. So this is our union find. So we will create this class of size n. How we'll do this? Let's see. We'll create a class union find, right? So this union find class will have what? Two things. First, its parent and its rank, right? So we'll take its parent value, parent node, right? And then that will our value, right? And then its rank. Two things. Okay, so we have taken the union find here of size n, correct? Let's see, this is union find, and this is our constructor. We'll say public, and size is what? We have given int, and we'll say this is our size, correct? Now we have to update our parent, right? So parent we have to initialize, so we'll say parent equal to new int, and this is our the given size is our parent size. All the nodes of the parent will have here. Now we will move to its node, right? Int I equal to what? 0. Then I should be less than what? Less than size, and then I plus plus. Then what we will do here? We will update all its parent by what? We'll say this is all nodes have its own parent, right? And we have its rank also, right? So we will have to update its rank equal to new int, and this is the size. Okay, we will initialize. These two things is done. Now we will create a find. We'll create a find function that will find its parent, right? So a parent node, you can say. So how we'll do that? We'll take a public return integer node, and this is the find function, and this will take int x. X is what? Our node, right? So you can pass node also, or x. Okay, Now what we will do, this is our if. We will pass parent of node we have given, right? Let's see, that is our x that we are talking about. If x not equal to what, x, means we will return what, we will find. If that is not there, then we will say parent of x is our, we have to find what, parent of x, its parent. We will go to its parent. If not, if parent of x not equal to x, means it's itself is, it is not, then we have to find its parent, right? If this is not the single node, then we have to find its parent. Now we'll do to return, and we'll say parent of x we have to return either, if we have, means this is the function to return the parent, you can say. Now we will do we will add we will do union of two function, right? So we will say public void and union. So this function will do what, will pass two variable, two nodes, int x and int y. So this node will do what, we will do let's see, we have a set of x, right? Yeah, you can say set x, right? This set x will store will get from what, find of what, x, and if we'll have set y equal to, will come from what, find of y. Two set we have. Now we have to do union, right? So what we will do, we'll check the condition if set underscore x equal to what, it's set y, set y. If that is the not the case, right, then we will do return, we will do return. Okay, we will not do anything. Otherwise what we will do, we will maintain if we will check its rank also, right? Its rank should be less than, right? So we'll say rank of set x, rank of set x is less than what, rank of y, rank of set underscore y. Two things we will take, rank of x and rank of y. If less than or equal to, right, less than or equal to, so first we will go with less than. If less than, then what we will do, we will say that parent of x, set x, parent of set x is what, our set y, right? We will maintain like this. If that is not the case, if that is not the case, means we have to pass what, rank of what, rank of set underscore x. If rank of set is greater than, let's suppose is greater than rank of set underscore y. If it is greater than, then what we will do here, we will say parent of set underscore y is set x, correct? Otherwise what we will do, otherwise we will say else we will do parent, we will set, we will do set underscore y is what, our set x, and our rank, we have rank of set x will do plus plus, right? Like this we can do that. Otherwise we'll increment the rank of this one. So now this function is ready. Now this class is ready. Now what we will do, we'll do what, good path. Let's suppose till now we have maintained everything done. Now what we will do, now we'll take our number of what, good paths. We'll take what, 0. Number of good paths we have taken. Now we will iterate over all the nodes with the same value in the sorted order, and what we'll do, we'll start from the lowest one, right? So what we'll do, we'll start from iterating, and we'll say int, we have a value, right? Int value we'll get from what? We have map, right? From the map, because we will have what? All its value from the key set, right? Then we have key set is a function, and we'll get our all the key in the form of set. So this will give you unique value. So for all the value we will move, right? Value of nodes, we can say value of node, you can say value of node. Okay, value of node. So this is unique value, right? Unique value of node. You can also say unique value, unique value of node. This is our unique value of node, right? What is this? This is the unique value of node, right? We'll get from the set. Either we'll say v only, value of node. Okay, now we'll take what we have a value. Now we'll check for every node we have the value, right? We will combine the set of the node and its neighbor into one set, right? How we'll do that? We'll make for loop, and we'll get each node. We'll have our node from what? We'll get all the nodes, right? How we'll get that? We have value. We have map of what? Map of values we have, and from there we'll pass this function, and we'll say value of node we will pass, right? So we'll get all the nodes that have the same value, right? That we will get. Now what we should do? We will check if it doesn't have the adjacent, right? So we'll make if we have adjacency list dot contains what we have contains key we have, right? And this contains key value will have some what we will pass this node, right? If adjacency doesn't contain this node, if adjacency doesn't contain this node, then we will do what? We'll continue our coding. Otherwise, if we have, right, so we'll take its what, or we'll get all the neighbors of that node. How we'll get that? We'll get adjacency list we have, right? And then we will get what? Get, and we have what we have? Node. So from the adjacency we'll get its all neighbor, right? So we'll take int nei, its all neighbor we have, neighbor node, we can say. We can write all also. So we have this neighbor node, and then what we will do, we'll traverse this neighbor node. We'll choose only neighbor with the smaller one, right? And no point in traversing all the neighbors, right? So what we will do, we'll make a condition here, and we'll say that vals we have, right? Vals we have already, this vals, and these vals contain what? Node, right? We will pass node, right? That parent node. If parent node, this is our parent node, right? If parent node, source node, you can say source node, this is the source node. If source node is greater than equal to what? Its neighbor, right? So what is the neighbor we have? We have vals we have, right? And we'll pass nei, correct? This one. If greater than its neighbor, then what we'll do? We'll do greater than equal to, right? Greater than equal to. Then means source should be greater than equal to its neighbor, right? Should not be less than equal to. Should be less than equal to its value, which can say its value should be less than equal to its neighbor value should be less than equal to its source, you can say node. And that's why we can say that node value should be greater than equal to its neighbor. That's the same thing. Now what we should do here, we will call our we have the union we have. here we have the union, right? So we'll call our union object and we'll do union. This is a union function we have already created, right? And we will pass two nodes, first its source and its neighbor, right? X and Y. That it will do automatically, right? That we have already done. Now after this, if we have completed this for loop, then they have completed this for loop, and then we have completed this for loop. So all the for loop we have completed here, right? Now what we will do here, now it's time to group it, right? Now we will group this one. So there is we have map, right? So from the map we will compute the number of nodes under observation with the same value, right? If the same value we have, then we will put into group, right? So for that, what we will do, we will make a right group. So this is our group, and this will be our what in the map. So has map, we'll say this is has map, right? Like this. So we'll go here and we'll say the map we have, and this will take two things, right? Two integers we have to pass, two nodes we have to pass. Integer, correct? Two nodes we will pass here. Now what we have to do, we have to iterate all over the nodes, and we'll get the set of each node, and then we will increase the count by 1, correct? So how we'll do that? We'll do for loop, we'll take, and we will have our mapper value, right? We have mapper value, we have, so called the mapper value dot there is a function, right, that we have called get function, because we have map, right? And for the map we will pass a value at a time, right? We will pass a value, correct? And this value will return what? Int what we can say, int u. This is recognized or not, because we have to take in this one. No, it's not taking. We have to take this one, I think, and we are coming from the out of the list, right? We have to put this into here, so that we will get. Now we will group, right? We'll do like this. Wait. Okay. Yeah. This is the loop, right? Now we have this number of node will have the value, right? And we will get from the map, right? And that is what we will get from here. We'll get a node, right? And this is our what at a time we'll get from its value, right? So we are iterating all the node, and we're doing union, right? So let's see, we'll say that this one we will get some its value, right? We are doing here, we are each node will set this is a set, you can say. We'll get the set of each node and increase the count by 1. We're doing that. So what we'll do, each value will get from here, u dot we'll do union, right? We are doing union. We have union object, and this will do find. It will find its will pass u, and the u, or you say x, you will remember. We'll pass our x value, x this one, and then we will do what? Group dot, there is a method get default, this one, and we'll call what? Union dot, we'll do find, we'll pass what? We'll pass x, and then we'll say there is another value, that is default value, and then we will do what? +1, correct? So we'll passing default value of that, otherwise if you have the value, then it will put, right? This part is also done. Now what we should do, we should do what? We have the for loop, right? We have for In this for, what we should do, we'll take int key is what, we'll do group, and from the group we'll get key set. So this function, we have all the groups, right? Now I will take size, and this size will come from what, group dot get, and we'll get what, key, and then we'll pass good paths plus equal to size into size plus 1, right? That we have did, and by do 2 divided by 2. Now after this we will return what, the path, right? Return good paths. Now we have number of good paths, right? This value. Number of good paths we have, this one, good paths, right? Number of good paths. So if we'll talk about this one, right? This one, right? So this is coming here, right? Let me compile this one. Update parent of I equal to I in the union find class, right? We are doing find, so that we have to update. Yeah, it's working. So let's submit and try. It's working fine. Thank you so much, guys. Please comment the time complexity and space complexity, and if you have doubt, please ping in the comment box. Thank you so much. We have taken the parent and key, right? And then we have created one union find, right? Then we have created a union find function in which we will pass the size, and we'll have our what, parent and rank will be initialized, right? Parent and rank will be initialized. Now we'll have a function, find function. This find function will return its parent, and there is a union function. That union will create a set of two given what, nodes, right? It will do. How will do that? We'll find its with the help of find, we will get its parent of x and y, and if both are same, then we will return, will not do anything. If less than if rank of x is less than rank of y, means we will do what, we'll set that parent of x is parent of y set, right? And similarly, if rank is greater than, then we will set parent of y is x. We will set, and otherwise will parent of y is x, or we will increase the rank. So these things we will do. After that, we have already did what, we have created adjacency list. We have maintained our adjacency, right? Then we have taken our what, this map of what, its node and its will take a rank and its all nodes value, right? Node value, rank value and node value, we can say. So we have taken rank is what, 0, some value we have for each node. So we have taken this, the value, as a rank, and all its node will come in the list, right? So this map will contain what, its value of the node and all the nodes that have the same value. After that, what we have did, we have created one union that we have already discussed, right? And then we will take the number of good path here, and the main code will start from here to here. Main code is here to here, right? So in this code, what we will do, we are doing what, based on the number of value of node, right? Based on number node, right? For each value, right? For each value will traverse all the nodes, right? If the node value have 1, right? So all the node that have the value 1 will traverse here, right? After that, what we will do, we will do here adjacency list dot contains method, and then we will do continue, and from the continue, what we will do, we'll move to here, its neighbor. If that adjacency doesn't contain, then we will not do anything. Otherwise, if it contains, then it will go to all its neighbor, and we'll do union of that neighbor if its value is greater than or equal to its neighbor. If value of the nodes is not greater than or equal to that, means we'll not do anything. That will not consider as a path. And if the value is greater than its neighbor, means we will do this one, right? Because the condition is already given. Its value, starting value and ending value should be same, but in the between that node will come, that should value be less than or equal to the its value, its rank. And that's why that things we have to do. After that, you will see that we have our map, right? We will do grouping here, right? And we'll do group, will from the map we'll get value, and we'll group using find function we'll pass, and this group will update our, we will update our group. From the group, what we will do, we'll move to all its key, we'll get the key set, right? And we'll size, we will have the size, right? Now we'll number of path we'll find by how size into size plus 1 by 2, and that will get our group. So there only things we have to take care of creating the group, right? So group is what? A map, right? So we have how many group we have, right? That we have already discussed. We have created one node, right? And for each node we will pass our value of node we will pass, and for all the value, how many nodes we have, how many paths we have, right? That we have calculated. And each time once we have all its all the group we have, right? All group value we have, like group and its value we have, means we will have our path also. So continuously we will find our path, right? Let me do this one and this one, right? So as you've seen, right, we will have each node, right? We are passing each node, right? If for the 2, how many nodes we have, right? How many valid path we have? Let's suppose we have 3. We got 3, right? If size is 2, right? Size is 2 into 2 plus 1 by 2 we are doing, right? And its value is what? 3. So we'll get 2 into 2. Now we have got 3. So number of path is what? 3 we have. Similarly, if we'll talk about size 3, right? Into what we have? 3 plus 1 by 2, right? So we'll count 2 will do into 6. And what we are doing there? We are doing 3 plus 6, right? And that's why we number of good path we will calculate like this. Previously, now currently is 3. Previously it was 3. So now this time the current path is what? 9. So like this we are calculating here, correct? And these things we will updating. What we will doing there in the group, we will add group. What we group will have for 2, for this 2, how many we have? Path 3. So we'll group like this. Now again we are putting this one in the map, so this will be look like this one. Next time what we have? 3. Now we are getting what? 6. So on this group we will make a loop, and for all the key, we have some value, right? We have some value, so we will add like this, and we will have our number of good paths, right? So that's all, guys. If you have any doubt, please ping me in the comment box. I will explain there. Thank you so much.